Hello, my name is Varun Mishra, and today I'll be presenting our work on detecting receptivity for mHealth interventions. This work was done in collaboration with colleagues at Dartmouth, ETH Zurich, University of St. Gallen, and the National University of Singapore. Recently, there has been a lot of focus and interest in leveraging ubiquitous technologies to deliver health and well-being interventions. One such intervention framework that is particularly popular is just-in-time adaptive interventions. JITAIs have been deployed in several studies and have shown to be effective for a variety of health outcomes. Fundamentally, a JITAI aims to deliver the right type or amount of support at the right time. So what is a right time? There are two key concepts when it comes to timing. First is a state of vulnerability, that is, a period of heightened susceptibility to a negative health outcome. For example, if the goal is to provide stress relieving interventions, then ideally the intervention should be delivered when the user is stressed or is about to get stressed. Here, stress is the vulnerable condition. Delivering stress relieving interventions at a time when the user is relaxed might not be beneficial. The next concept is state of receptivity, that is, periods when users are able and willing to receive, process, and utilize the support provided. For example, delivering stress relieving interventions when a person is giving a talk might not be a good time, even if the person is stressed. Hence, detecting both vulnerability and receptivity is important for an intervention's effectiveness. In our work, we focus on the receptivity component. In our prior work, we conducted a 6-week-long study with 189 participants in Switzerland, where we deployed a chatbot-based digital coach called Ali that provided physical activity interventions aimed to improve daily step goals. Through that initial study, we defined the various metrics of receptivity that are also utilized in our current work. Ali initialized each conversation with a greeting message, like good morning or how is it going. We defined several metrics to measure receptivity around these initiating messages. First is just-in-time response, that is, did the participant reply within a short period of time. In our analysis, we used a window of 10 minutes. Next is response delay, that is, the time taken to respond to an initiating message. And third is conversation engagement, that is, did the participant engage in a conversation with the chatbot. From the Ali study, we reported several interesting associations and findings. One of the most important findings was the feasibility of building machine learning models that could leverage the various factors and detect receptive moments. In this work, we decided to build on our prior work by actually deploying the machine learning models with participants in the real world. In the initial Ali app, the server sent a push message at random times during the morning, afternoon, or evening blocks, and the app displayed the message and notification as soon as it received the push. In this work, we modified how the app notifications worked. The server still sent a message at random in the morning, afternoon, or evening, but the message was silent and was intercepted by the receptivity module that we added to the app. The receptivity module would use the contextual information available at that time to determine if that time was a good time to deliver the message. If it was, then the app would notify the user, else it would try again after a few minutes. We implemented 3 different intervention delivery methods in our receptivity module that it would choose from randomly when it received the silent push from the server. The first one is a static model, which was a random forest model that remained the same for every participant for the duration of the study. The next is an adaptive model, which was a logistic regression model that was retrained on the fly using data from individual participants. And third was a control method that simply delivered the prompts at random times. We trained the machine learning models using data collected from the 141 iOS users from our previous Ali study. The Ali Plus app was only available on iOS. For more details on how the models were trained, please refer to our paper. Here's a quick schematic diagram of the entire process. At a random time in a time block, the server would send a silent push to the Ali Plus app. The receptivity module would receive the push and randomly decide which delivery model to use. For the first 7 days, it would only choose between the static or the control methods. After the first 7 days, once sufficient user-specific data was available, the receptivity module would randomly choose between static, adaptive, or control methods. If the control method is selected, then the notification is triggered immediately. However, if an ML method is selected, then the app uses the in-the-moment contextual information to determine if the user is receptive. If the model predicts that the user is receptive, then the notification is triggered. If not, then the model kept trying every 5 minutes for 30 minutes. After 30 minutes, the app just triggered the notification as control. After the notification was triggered, based on how the user interacted with the notification, the adaptive model was updated for future predictions. So, to test the efficacy of these models in real world, we conducted a 3-week-long study with 83 participants from the US East Coast. Our analysis revealed that over the course of the study, participants were up to 40% more receptive to messages delivered by the static model as compared to the control method. The messages delivered by the adaptive model did not show any significant difference in receptivity than the control model. However, when we looked at the day-to-day trends, we noticed that over time, the adaptive model's performance improved. Consider this plot of likelihood of conversation engagement and the day in the study. We noticed that the static model led to consistent engagement levels throughout the study duration. The control model, that is delivering prompts at random times, led to a significant decline in the likelihood of conversation engagement over the study duration. However, the adaptive model led to a significant improvement in conversation engagement over time. In our paper, we discussed the various analysis methodologies, results across the different dimensions of receptivity, and the limitations of our work. We encourage you to read the paper for more details. Our results are very promising and show that it is indeed possible to detect receptive moments for intervention delivery. As next steps, we are currently building better models that move beyond just momentary features and consider more temporal information. We are also planning another deployment from a longer study duration to evaluate how different personalization methods will perform. Thank you for listening, and please feel free to reach out to us for more details.